Okay, today we are solving systems by substitution. We are going to do this today and in 3.5. We have already solved systems by graphing. A system of equations is still a collection of two or more equations. And our solution is still the point that makes both of our equations true. Which when we get done solving today, I will show you that we can check all of our solutions. Okay. I've got 6 steps to solving a system here. Really, it's just 2 steps because these are kind of together. So step 1 says solve one equation for x or y, and it is crossed out because that has already been done for us today. Thursday, however, in 3.5, we are going to have to do that step 1. So it's crossed out for today because we don't have to do it today, but on Thursday we will. Steps 2 and 3 are to substitute the equation that's already solved for x or y into the other equation. So we're going to take one equation, we're going to substitute it into the other equation. Then we solve for one variable. Then steps 4 and 5 are to take that answer, plug it back into the other equation, and solve for the other variable. Once we get that done, we write it as an ordered pair. Just a reminder, in ordered pairs, x always comes first. I'm going to put x comma y right here. It's a nice little reminder that x comes first. Okay, so follow along as we go. If you don't know what's happening, ask about it so I can re-explain that step then. Don't wait until the end and then say, oh, I didn't understand the first step. Okay, so we're going to go step by step. Step 1 would be to solve one equation for x or y. In this first system, my equation right here, y equals x plus 8, that is already solved for y. So this is y equals x plus 8. And so since that is already done, I am ready for step 2. Step 2 is to substitute the equation that's already solved for one of my variables into my other equation. You have to substitute it in for what it's solved for, though. So since this is y equals right here where the y is, I can put in the x plus 8. Since I know that y equals x plus 8, I can replace a y with an x plus 8. So what that's going to look like is I'm going to rewrite my bottom equation. It's going to be 3x plus 3. And then instead of the y, I'm going to put in an x plus 8. And then I keep finishing it out and write the equal 6. So all I've done so far is take this x plus 8 and plug it in for y. Okay, so that is step 2, is substituting. When I substitute, I replace. So I replace the y with an x plus 8. And the reason why I'm allowed to do that is because y equals x plus 8. Okay. From here, I solve. So I need to distribute, combine like terms, solve for x. So I'm going to distribute this 3 to x and 3 to 8. So this stays 3x. 3 times x is 3x. 3 times 8 is 24. Equals 6. So I've distributed now. Now I can combine like terms. So 3x plus 3x is 6x plus 24 equals 6. And it's just a couple more steps to solve. I'll subtract 24 from both sides. I'll get 6x equals 6 minus 24, which is negative 18. And then I divide both sides by 6. You get x equals negative 18 divided by 6 is negative 3. Weird looking 3. Sorry. Okay. So that was step 3, was to solve my equation for my first variable. Okay. Does anyone have any questions right now? Okay, so recap of what we've done. We knew y equaled x plus 8. So we replaced this y right here with an x plus 8. Then we distributed the 3. That's how we got 3x plus 24. We combined like terms, so 3x plus 3x was 6x. And then we solved for x. Okay, any questions right now? Okay, so we are ready for step 4 then. Step 4 is to substitute this solution that we just got back into the other equation. So we've used this equation, the 3x plus 3y equals 6, because that's what we started with here. We're going to use the other equation now. So I'm going to come write it over here, so I've got it fresh where I can use it. Y equals x plus 8. Now that I know that y equals x plus 8, and I also know that x equals negative 3, I can plug this negative 3 in right here into that x right there. So I will have y equals negative 3 plus 8. Thank you. And then we'll solve that out. Negative 3 plus 8 is 5, so I get y equals 5. So that was step 5, was solving that out. And then my last step is to write my solution as an ordered pair. So in an ordered pair, it's going to be negative 3, comma 5, because x always goes first. So negative 3, comma 5. Okay. Any questions right now? I know it's a completely new process. We're going to go through it several more times, and then we're here to help you while you guys work on your assignment. But does anyone have any questions right now? Okay, there's one more thing that I want to show you guys with this, which is how we could check our answer. So I now have negative 3 comma 5. That is my answer. This is an x value. This is a y value. I'm going to do it over here in this little space. If I wanted to check my answer, this x and y value would need to make both of these equations true. This is what we did in that maze yesterday, was check solutions. These solutions should all work. So it would be 5 equals x plus 8, so negative 3 plus 8. When I come to do negative 3 plus 8, I get 5, so that one works. And then it would also need to work in my other equation. So that would be 3x, so that would be 3 times negative 3, plus 3y would be 3 times 5. and that would need to equal 6. So it would be 3 times negative 3 plus 3 times 5 would need to equal 6, and it does. So just wanted to show you guys that if you are ever unsure about your solution, you can plug in both your x and y and check them both. Okay, any questions right now? Okay. Let's move on to our next one then. So our next system is 3x minus 2y equals 19 and x equals 2y plus 5. So the first thing that we need to do is identify the system that is either solved for x or solved for y. Do we have an equation solved for x or solved for y? So we're looking for one that's either x equals or y equals. Do we have one of those? Okay, which one? X equals. Okay, so we've got an equation that is x equals 2y plus 5. So since this is x equals 2y plus 5, we can plug that into our other equation for x. You can only plug it in for the letter it's equal to. So since it's x equals 2y plus 5, we can plug that in for x. So we're going to do 3 times 2y plus 5, because we are substituting in the 2y plus 5 for the x. Minus 2y equals 19. Okay. Any questions about step 2, which is substituting in? Okay, so from here, then we solve. So I'm going to do 3 times 2y, 3 times 5. 3 times 2y is 6y. 3 times 5 is 15. So I've got 6y plus 15. And I still have my minus 2y equals 19. Okay, I'm going to combine like terms. So 6y minus 2y is 4y plus 15 equals 19. And then I'll subtract 15 from both sides. I'll get 4y equals 19 minus 15, which is 4. And then I'll divide both sides by 4. I will get y equals 4 divided by 4 is 1. So I will get y equals 1. Making sure you know whether you are solving for x or y is super important on these problems, because if we don't know whether we're solving for x or y, we don't know what we can substitute it in for. Grab one of those, please. Okay. Any questions about that one? Okay, so then we have now solved for y. We need to go solve for x. So we are going to come up here to x equals 2y plus 5. We'll use that equation. We now know that y equals 1, so we can plug in 1 for y. So this is going to be x equals 2 times 1 plus 5. So I'm plugging in my known y value for y. And then I can do this math. 2 times 1 is 2. So I've got x equals 2 plus 5. And then 2 plus 5 is 7. So I get x equals 7. Okay, my ordered pair then is 7, 1, because x comes first. So sometimes you'll solve for x first, sometimes you'll solve for it second, but when you list your ordered pair, you always list x first. So my ordered pair is 7, 1. Put your phones away, please. Hey, any questions about solving for x and y here? Okay, so then again, I want to show you that we can check these. So to check this, I would be plugging in 7 for x and 1 for y. So I would do 3 times 7 minus 2 times 1 equals 19. So I got that from right here. 3x minus 2y equals 19. So that'll be 3 times 7 minus 2 times 1. Make sure that equals 19, which it does. And then the other piece we're checking is x equals 2y plus 5. So that's going to be 7 equals, that's x 2 times 1 plus 5. Two times 1 is 2, plus 5 is 7. So 7 equals 7, and that one works out. Hey, any questions on either of those? Okay, flip this over. There are 2 more examples on the back, but the 2 more examples on the back are special scenarios, so they're actually going to be way faster. We've got to do the first couple of steps, and then we don't have to finish solving them out, and you'll see why. So this first one on the back, 2x minus 6y equals 8. We've got x equals 3y plus 2. Because this is x equals, we can take that 3y plus 2. We can plug it in for x. So we've got x equals 3y plus 2. We will plug in the 3y plus 2 for x. So we're going to have 2 times, we're plugging in 3y plus 2 for x, and then we still have minus 6y equals 8. So 2 times 3y is 6y. 2 times 2 is 4. And then I still have minus 6y equals 8. Okay, now we go to combine like terms. What is 6y minus 6y? 0y. So our y's cancel out here. And we are left with 4 equals 8. Throwback all the way to unit 1. I think this was like 1.5, 1.6, something like that. If our variables cancel out and we are left with something that is false, I'm going to write a little note of what's happened. Variables have canceled, and we are left with something false. I'm putting it in parentheses because those are just notes. It's not what happens. Our answer is that we have no solution. The equations that we are solving are just like the equations that we graphed. These are not set up nicely to be graphed, but if I were to graph those two equations, they would be parallel, they would never cross, I would have no solution. But we're not graphing them, we're solving them algebraically. Because they're not set up nicely to be graphed. Okay, Josh, did you have a question? All right, I saw a hand. All right, any questions on that one? Okay, we've got one more then. The last one we've got is 2x minus y equals negative 8 and y equals 2x plus 8. So we are going to be plugging in this y equals 2x plus 8 for this y right here. Anytime I have a y or an x that's just by itself, I can put an imaginary 1 in front of it. So I'm going to put an imaginary 1 there. It's going to make my life easier. So this is going to be, I'm plugging in for y. So it's going to be 2x minus 1 times, plugging in for y, is 2x plus 8. And that equals negative 8. Okay. So this stays 2x. Negative 1 times 2x is negative 2x. And then negative 1 times 8 is negative 8. And then that is equal to negative 8. Okay. This 2x minus 2x cancels out. So I am left with negative 8 equals negative 8. So this is the same thing that happened on the last one, except for it's true. If our variables cancel out, and we are left with a true statement, anybody remember what our answer is? I heard somebody say it. Infinite. Infinite, yes. Infinite solutions. Okay. So we substitute in, solve for our first variable, substitute that in, solve for our second variable. If our variables cancel out, though, that's when we get no solutions or infinite solutions. Does anyone have any questions right now? Okay, we are going to give you guys the rest of time to work, which is like 47 minutes. Your assignment only has 6 problems, and there's one of these and there's one of these. So it's really only 4 you have to solve all the way out. We are here to help you, but you've got to help